So topic says understanding time in structure streaming. So there are too many things here. What I'm going to talk today is a very specific topic. So what I do is that since we have a variety of people, I will take some time to get some of the introduction in, then we'll get into the session. So I will give you a background of this talk. So in one of our Meetup, we talked about something called structure streaming. Right? So I think most of you know what the streaming is, analyzing the data on the real time. And structure streaming is one of the API that got introduced in Spark 2.0. Yeah, so what I was saying is that structure streaming is a new API which came in 2.0, but it's not just an API. It's a new way of thinking how the structure streaming or streaming system should be. And one of the aspects of streaming is time. Right? Whenever we talk about streaming, we always talk about time. Is it batch time, window time, or source time? There are so many different things. So what we have thought is we will have a dedicated session where we explore why time is important in the streaming and also how structure streaming allows you to play with the time much different than what you have seen in other streaming systems. It's not just for Spark, but if you have used the Storm or if you use Samza or if you use any other system, this kind of gives you a different perspective on it. And if you see the new generation streaming system, particularly Beam, Flink, maybe you have heard these names at least, right? They kind of go about in the same way what we are talking about. So even if you don't use Spark, but if you are using any other streaming, maybe this talk is useful to you, where you can kind of correlate what you've seen in other frameworks and say, okay, maybe this is how we talk. Okay, so what we are going to focus on is time and window API. And if you are interested in the code, you can clone this repo and you can go from there. Okay. Of course, I have not introduced myself. My name is Madhukara Phatak. I am a team lead at TeleUS and also I run a company called Data Mantra where I consult on Hadoop, Spark and Scala. And if you are interested to know more about me and if you want to find me in the social media, you can go to this website. Okay. Now, this is kind of an agenda. So when I put together agenda, so initially I just wrote all the slides for a talk, then I kind of thought, oh, there will be people who never heard of structure streaming. Maybe completely new to that. That's why I added a second line where I give a very brief introduction to structure streaming because last time it took us 2 hours just to talk about the introduction to structure streaming. I'll be not able to cover through everything, but I'll give a very brief introduction. What is the structure streaming all about? Then we'll get into actual talk. So what is the agenda? Agenda is evolution of time in stream processing, which means kind of very high level why time is required and how people look at time in different systems. That's the one thing. And second one is then the structure streaming, then we'll go through the API and actual code. Okay. Now, one of the things is that in my slides, there is no slide which says any questions. So if you guys have questions, feel free to ask in between also. Okay. So before we start with the time, let us ask some questions. So how many of you seen Inception? Okay, few of you. How many of you seen any kind of a time travel movies? Most of them. Okay. So if you look at movies, time plays a very important role, right? In a normal movies or particularly in this sci-fi or time travel movies. Why? Because when you are watching a movie, you have to differentiate, is it a scene happening in the current or happening in the past? Right? A lot of movies use this concept of flashback. How do you know you are going to flashback? There will be a transition effect, right? Otherwise, or there will be black and white. Somewhere they say you are in the flashback because you have to differentiate between the time. Are you able to follow what I am trying to say? Similarly, when we come to streaming, we need to differentiate about the time. Here, there is no flashback, but there are different kind of time we have. Are you able to follow what we are trying to say? So it means time plays a very important role, but how people look at time is different. So let me give an analogy, very simple. The initial movies, particularly 80s, 90s, they have a single timeline, right? So what happens then? Initially there will be hero, then there will be heroine, then there will be love song, then there will be villain, then there will be action, then there will be pathos song, and there will be climax. Are you able to follow? That is one way of looking at time. So there is one stream of line which you can easily follow. But after a few years, people started experimenting, which means first itself is a climax. You may be seeing a hero in a very bad shape, then it will go to flashback. People say, okay, why you got into it, etc., etc. That's kind of a reverse way. Does it make sense? But then people start to become clever. What they started doing, kind of cutting between interplay, which means you see a past, but you then come to present and you start correlating. Particularly like movies like Rajini and those kind of scale movies. Which means people started playing with the time because that gives a different effects. Similarly, in the streaming system, when we started with the time, it was a very simple idea. We say, okay, we start with one and everywhere it's the same time. But once the streaming system became complicated, we needed more important time. So let us see what is that time means here. One of the things about streaming compared to batch, time is the king. Because when we are doing a batch processing, we don't really care about time per se. What I really cared about is how many data points I have, that's the rows or maybe size of the data. Can I process this information? Can I get the output out? Does it make sense? When you are doing a batch, only thing what we talk about time is more of our business problem. I can say I want to do it for the last 6 months, but when the processing is happening, I'm not talking about anything like that. I say I have 10 files, I want to process, I will get the result done. But when we are talking about streaming, it little bit changes. How it changes? Time plays a major role. One is that what we want to do in streaming is always tied to something called latency. Are you able to follow why we do stream processing? First reason is latency, because batch processing takes a lot of time. I wanted to do it much faster. But to do much faster, you cannot do everything. Does it make sense? Right? So for example, if I was doing a machine learning in my product, maybe you don't want to do machine learning in the stream, in the first row. Right? What do you want to do? Maybe some of the data cleanup, some of the aggregation, some of those. Why? Because you are always want to know what is the latency. Can I get this in 5 minutes? Can I get this in an hour? Not like after a day or something. So latency is the first one which allows people to go from batch to streaming system. Does it make sense? Okay. Second one is window time. Right? How many of you heard window time? Right. So think window time is like in the movie, it's like how long a given scene can go. Right. For example, the scene starts, there will be context, but after some time, scene has to stop, right? Which means the context should go to another location. What is a window time in our streaming processing? It is the state what the user wants to keep around. What that means, for example, let us say I'm doing a stream processing. I want to know what happened in last 1 hour. But that 1 hour keeps on changing. Are you able to follow? Why I don't keep more? Because it takes more memory, more resources. Which means in a batch processing system, I can say give me last 6 months of results. But in the streaming, I restrict myself how long I want to remember. Does it make sense? Okay. Now, what is a batch time? So batch time is not really something comes into from the application. It's a more of a framework construct, which means when we talk about a stream system, we don't talk about batch time. We typically talk about latency, which means how fast I want to do. We also typically talk about window time, which means how long I want to remember. Batch time is a construct which comes from the framework which allows you to do this combination of latency and window time. So batch, what it says is how long you want to wait before you want to start doing processing. Now the question is why? Why I want to wait? Can I do as soon as possible? Depends. Sometimes there may not be enough context to do anything. Maybe I just have a 10 record. I cannot do any processing which is realistic. So what I can do, I can wait for 2 minutes, get enough data, then start doing something. Similarly, or there may be another thing. If I'm doing every record, it may be costly for me. Then I'll say, okay, it's fine. Anyway, I'm waiting for 30 minutes to get a result. I can do for every 5 minutes. Are you able to follow? That's another kind of time. So this is the first three. What I've talked about is more of a framework point of view, which means when I'm thinking about streaming, I'm always thinking about this kind of time. But if you see the business question, what we ask in the streaming, they are also very time centric. What that means, for example, if you go to Twitter, right, it's one of the most famous streaming system. What the questions you ask? What is trending in last few minutes? And you never ask what is trending, because what is trending keeps on changing from last 30 minutes to this 30 minutes, which means time is very important. Then when you go to feed, it's also chronological, right? You want to see what happened in last few minutes or few hours, but you never go like in Facebook where you kind of dig through multiple years. It's very rarely we do it in Twitter. So very similarly, a lot of business questions what we ask in streaming is very centric to time. which means time plays a big role both in terms of your thinking process or in terms of coding or in terms of approach, but also in terms of business. You are always talking about time in the stream. So that's why time is very important. Now, as I told you about movies, the idea of a time is very simple when the streaming system started, right? It's very similar to what like if even if you see physics, right? What is a time? The idea was very simple before Einstein came along, where time is something which is always there. But then Einstein came along and said, no, there is a relativity, there is a different times, and etc., which made things complicated. Very similarly, what was the time in stream processing is, since stream processing came for latency, so idea of stream processing was it's a faster batch processing. There was only one time that was optimized for latency. What that means is that if the batch takes 1 hour, it's the same idea but just runs in 5 minutes. Maybe small amount of data, small amount of calculation, but there is nothing special about it. That's how the streaming system started to think. If you look at Storm or even earlier like a DStream API, that's a simple idea. Let's say there's one time, there's a latency time, and we are optimizing for that. So latency differentiated between batch and stream, which means if you are able to get it in 1 minute, okay, that's your streaming. If you are able to get it in let's say 5 to 10 minutes, that's your batch process. That's kind of way people started to think. And latency informed window time and batch time. So that's another piece, which means depending upon how you develop the code in the DStream, that dictates how long you can take a window, and what is that window also dictated by the time what is kept by the processing system. There is no other time. There is only one linear time. When you start from your program, the time starts and till you end the program. Right. Now that was good for when people started saying, okay, stream processing is just a faster batch processing. But as we are getting into this new era where stream processing by itself is a new tool rather than just seeing as a faster batch processing, this view of time is not good enough. Are you able to follow what I'm saying? For example, just to give an analogy, why people wanted to have like a theory of relativity. Reason is simple. If you are sending a satellite which is so much like a distance from Earth, they cannot be on the same time. You have to accept that fact, and you have to start calculating what is that difference and how we can accommodate that. Similarly, the newer systems, what we are building, for example, maybe you are building the systems where you want to correlate data from multiple systems. Now, if you have a different time in different systems, you have to accept that and say how you can correlate. And also, if there is a delay in the data what you are getting, you need to still correlate, right? Maybe they have originated in the same time, but when they came to processing system, they are delayed. But you cannot say, since they are delayed in processing system, I will not be able to correlate. So for the new generation system, this kind of a time is not good enough. Now, why we need a different time abstraction? So this is what I was talking about. See, if you look at a streaming system, it has multiple components, right? One of them is source, where normally the events are generated. So this source can be a log file, this source can be a sensor, anything. You can think of any any problem, there will be a source where actually the event is generated. Then typically we have this ingestion system which temporarily keeps the data for some time, because typically the sources are not able to keep the data for long, particularly things like sensors and those kind of things, they cannot remember for long. What you need, you want a kind of intermediate storage where you can store the data for long, and they are like Kafka. Right? Kafka is kind of a temporary storage where you keep the data. Of course, you use a Kafka for other reasons. There's a distributed and those kind of things. But in terms of business, why you want to keep it? Because your source is not able to hold it for long, and you can have multiple sources, right? You may have multiple sensors, or you are having sensors plus something else. That is your ingestion system. Now, of course, there is a processing system, let us say Spark Streaming, Storm, and etc. If you see, there are multiple systems, and of course, these systems sits in different places, right? Maybe your sensor is sitting in your customer space, your Kafka and the processing system is sitting in your data center, and they are connected by a network. So when there is a network, of course, there are delays, which means maybe sensor is running on a different timeline compared to your processing system, because your processing system has all this fiber network, but sensor has this, like let's say, Wi-Fi network or also your mobile network. So there is always delays, which means what is the time you see in the sensor may be a little bit different than what is the system time you're seeing in the ingestion system, or it may be different in the processing system. Why? Because processing maybe got slow, right? There was a bug and it was taking more time. The data is already there in the system, which means we already seen the data, but we have not yet seen the data in the process. Are you able to follow what you are saying? So it is. I will give another analogy here. It is like making a video call in Skype or something, right? So there is always delays, which means the person is already explained, and out of 10 people, 5 have understood, but other 5 are still should be able to catch it. But think of a system where in the Skype and all, you just don't bother. If they say 5 people have heard, I'll just skip the other 5. It cannot happen like that. So people has to catch up. Similarly, systems should be able to catch up over a time, but what the information you get should be exactly same. It cannot be like because you were delayed or something else, you are getting a different result altogether. So for this, we need a different time abstraction, and introducing a different time abstractions is not so easy, right? People, if you have worked on any kind of time analysis in your program, you know how hard it is. Just for Earth, there are so many time zones, and then there is a daylight saving. Then you have to understand what is this different calendar. Now imagine you are in the solar system where there is a delays, right? 8 o'clock is not really 8 o'clock, not even like in the GST or IST. It's a different altogether. That is much harder to think about compared to your typical timing system. So that's why we need a different time abstractions. Now, what kind of time abstractions we are talking about? So we kind of told that okay, there is no single time abstraction, but then what are the different time abstractions we need? So we'll start with the easy one, process time. So what is a process time? Process time, so normally when I talk about time, it is a clock which is kept by some system. Very simple, right? So when we talk about time, what do you think about? It's a clock. So what is a process time? Time is tracked using a clock run by the processing engine. Does it make sense? When a processing system comes along, like a storm or spark streaming, it starts a timer saying that okay, I have started at 9 o'clock. Now it's 9:30, which means 30 minutes have passed. Okay, does it make sense? And most of the systems, the initial system, this is the default time abstraction. What is the meaning of default time abstraction? So if I ask a question, give me data for last 10 seconds. What is the meaning of that? Are you able to follow? Now there are 3 systems. There is a source system, there is an ingestion system, and there is a process system. If I ask a Spark, give me data for last 10 seconds. Is it at last 10 seconds in the source? Because there will be always delays. Is it the last 10 seconds in ingestion, or is it the last 10 seconds in the processing system? Processing system. Do you follow how it starts getting complicated? Right. So last 10 seconds means the records arrived in the processing in last 10 seconds. They may have created an hour back, or they may have created like 5 seconds back there. Here, when I say last 10 seconds, it always means last 10 seconds in the processing. Does it make sense? Are you able to follow? Now, the last line I have added for a very important reason. Implementing process time is very easy in the framework. Why? Because clock is governed by the processing system itself, which means it can make sure that the time is right. But it is hard for application developers. Why? Why process time is hard for application developers? Because when I asked the question last 10 seconds, I was not cared about last 10 seconds in the processing. What I wanted to know, give me the last 10 seconds result in the source. Does it make sense what I'm trying to say? So question I'm asking, give me the result of last 10 seconds. By the question, what I mean is whatever was generated in last 10 seconds in the source, not in the process system. Which means asking a question in this kind of time becomes very hard now. Because I cannot just assume that last 10 seconds is the source last 10 seconds. I have to somehow correlate, okay, this was 10 seconds in the source, but here it may be last 30 minutes. So what we do, we start to keep this buffer, right? What we do is that we say, okay, if I want to get last 1 minute, maybe it's good to just ask 10 minutes. And then figure out, okay, do I get the data in that 1 minute? Which means you kind of start thinking that, okay, there will be anyway a delay. then we will do. It's very similar to how we set up our meetings in our office, right? If I want to meet at 11 o'clock, I say, okay, by 11:30 people will show up, so it means I have enough 1 hour to go with. Similar idea here. So it is very easy to implement for framework. That's why a lot of frameworks started with the process time, because it's fully governed by the process time, and there is no delays in process time. Why? Because since we are only cared about the data which came into processing, after that there is not going to be a delay. This means there is no concept of out of order or those kind of things in process time. Does it make sense? Now, what is the opposite of process time? It's an event time. Right? So, how many of you heard this word? Event time. It's a pretty buzzword, this, right? So, what is the event time? Event time is the birth time of an event at source, which means this is when actually the event has fired, maybe in the sensor or maybe in the log. So, which means this is kind of opposite. This is what we really asking for. So, event time is the time embedded in the data, which means this is not a clock which is tracked by the processing system. It is a clock which is tracked by the source. And what the source does, it embeds that information into the data itself. Why? Because you cannot go to the source system and ask for its clock. And it has to communicate that it's got created in 10:30 p.m. It has to embed that data and give it to you. Now, when I say last 10 seconds here, this is what really we are asking for. We are saying, give me the last seconds in the source. Does it make sense? Okay. This time is independent of clock by processing time. Maybe here we already have moved on, but when I say 10 seconds, I still mean the 10 seconds in the source. Now, this is hard to implement in frameworks. Why? Because now you have to differentiate about different sources. You have to also differentiate about, okay, is your clock is already gone forward, out of order, all those kind of things becomes harder to implement, but it's very good for application development. Why? Because when I ask a question, that's the answer I am getting. Now, are you able to follow why event time was not the default abstraction in the initial frameworks? Because it is very hard to get it right. But for a developer, people say, okay, buffer is fine. I will keep a buffer, I'll ask a processing system question. If I get the answer, I'm happy. Now, these are the two extremes. But as I told you that there was an in-between movie structuring, right? Like only direct, like climax to begin. So that's what is this ingestion time. Now people say, okay, event time is great, but I cannot really control the event times. Why? Because you know network and there will be disconnection, too much work. Now can I get something in between? I don't like processing time because that's too much different, but I don't like also can get event time. That's where this ingestion time comes into picture. What is the ingestion time? It is the time at which it actually got landed into that temporary storage. Right? Why I'm really want this? Because this is more predictable compared to my event time. Because whatever my ingestion system and my processing system, it is much well connected and I can control that environment compared to the actual system. So when I say last 10 seconds, what that means? Last 10 seconds of data which landed in Kafka. That's what the answer I'm getting, which is still okay for me because that may be very much correlated to the source unless the source is very much delayed like an hour or so. Are you able to follow me? So the ingestion time is kind of in between that. That's the one thing. There's another problem in the processing time. Not a problem, but a challenge is, see, when the processing time is calculated, it is not a single clock, right? Because in a cluster there cannot be single clock. What you do is that every machine keeps a clock and it embeds the time in it. But sometimes what happens is that there are some discrepancies between the two different systems. You may get a place where you are embedding the wrong time. Which means someone is saying 7:30, but maybe I'm a second back there, I'm putting a wrong number. So for solving that, ingestion time is better because when the ingestion happens, I put a timestamp, done. Which means when I come to processing system, even if I'm doing a cluster-wide processing, I will not get affected as much of that. Of course, if you are having a Kafka, it will also make sure that Kafka has to run this NTP and all this time synchronous stuff. That is much okay in the ingestion time because ingestion is not really heavy, but in the processing time, keeping everything in sync is much harder. So that's why what people do is that they go with the ingestion time compared to the processing time. Again, ingestion time is also a little bit tricky to implement because it's always source dependent. Which means if you are connecting to different sources, not all the sources may expose this information about the time. Kafka and other ones may, but there may be a system where it may not be exposing that information. Then what happens is that you have to call back to the opposite. Does it make sense? I see faces all like okay, going great, but you never know. Okay. Am I going too fast or all are able to follow? Alright. Cool. Now, so I think in my heading there was understanding time in structure streaming. I think now everyone understood what is the time I am talking about. Now there is a structure streaming line. So what I am going to do is that I am going to give a very brief introduction to structure streaming before I kind of show you how to implement this different abstraction in structure streaming. That's the overall idea of this talk, where we will talk about different abstractions and how you implement this abstraction in the API. So what is structure streaming? Now, structure streaming is a new streaming API introduced in Spark 2. So earlier it used to be called as Spark streaming, and it was based on top of RDD API. But in 2.0, they have introduced a new API called structure streaming. Now, I'm very specifically pointing out that it's an API, not the runtime. So it's still your micro patch. All those things are still relevant. It's not like real time compared to Flink and Storm, but it's a new way of approaching the streaming. Now, why it is called as a structure streaming is, in structure streaming, a stream is modeled as an infinite table or data set. Now, what is an abstraction? Because if you look at the DStream API, what is a stream? It's a collection of micro patch, and the collection is an RD. Does it make sense? But in structure streaming, there is no inherent API, like an inherent idea that there is a micro patch. We never talk about a patch, but it's just an infinite table which goes forever. And on this table, you can ask queries. That's kind of an idea of structure streaming. Since we are using the structured abstraction because data set and data frames are for structured data, it is called as a structure stream. Does it make sense why it is called as a structure stream? I think people are grown. If you always call Spark streaming, then there is confusion. Right? Which Spark streaming you are talking about? Structure streaming is easy way to say, no, this is part 2 of the same idea. You can, so actually the way dataset handles unstructured data is, it is a structured data with one column, something like that. It's like one column with a string data, and that's your unstructured. Okay, all input sources, transformations, what you write, they are modeled after dataset, which means if you already, how many of you have worked in data frame APIs? Spark SQL, alright. So you will like it because you can now write all those SQL things on streaming. Now, one of the trends in the industry is SQL never goes away, right? It will always come back even after this whole no SQL idea. So ultimately, how you write a stream processing is you write them using SQL, or you can also using a dataset DSL, which is very similar to like a data frame DSL what we have seen in last year. Now, you may say, okay, why change abstraction? Why isn't it people are happy with these streams and all those kind of things? One is that one of the complaint people have had for long is all the APIs except streaming got moved into dataset and data frames. If you look at from Spark 1.3, everything like your normal processing, your ETL, your machine learning, everything got moved into data frames, all those nice SQL. But people who are in the streaming were suffering from using RDD API. Right? Only for streaming you had all this RDD abstraction. That's one, which means all the performance benefits which you got in the data frame and dataset API, that they are not there in the streaming at all. That was one of the biggest motivation to people to say, okay, let us move on to a data set rather than moving on to a existing RDD API. So that's the one. Second one is that if you look at the structured streaming or streaming processing, we're still talking about structured data. Right? What is your data input? Your JSON, XML, CSV, maybe even sometimes your RDBMS change log. These are structured data. So as we realized in the batch processing, 90% of our data is structured data. Why not just do it for streaming also? Which means all your schema inference, schema thing, all those you want in batch, you also want it in the stream system. So what this idea is that now you get all those benefits what you got in batch also in the structured stream. So that is the one thing, which means structured data analysis is a first class rather than laying over. How people used to do they used to use read a D stream, convert it to a RDD, and then register as a temp table, and then they used to 12. Right? A lot of people may have done it, but that's not a good experience. Right? When you do a join, it's like too much work. This gives you a first-class API where you don't have to do all these things. Another one is that it's easy to combine with the batch data. That's one of the biggest advantage of Spark, actually, where you can combine the data in the batch with your streaming system. Since both now batch and streaming system are talking about the same APIs, now it's very easy. I can read the data as a data frame from both the APIs. I can combine those data in order to enrich that data information in my system. If you don't really follow what I mean with this, you can watch my earlier talk where I've kind of gone through each of how to do those in the structure stream. Another one is, of course, people, if you have done the SQL, you can use all the SQL power now on the streaming also, which means you can write aggregations, you can do all the windows, joins, etc. in the SQL rather than have to learn its own API. Benefits from SQL optimization, which we already talked about. Easy to learn and maintain. Why? Because now people have to only learn data frames or data set abstraction. Don't have to learn RDD just for streaming system. So both kind of uses the same ideas and same abstraction. That is the one. One thing which I have missed in the slide is that when people are starting to go with the DStream API, if you see the micro batch was kind of there in the API itself. Why? Because if you look at the DStream API, how you start your program, you say streaming context, then you give batch a time. Right? Which means there is no way the Spark can support a non-micro batch implementation using that API. Does it make sense what I'm saying? Which is a similar problem we had in RDD, right? In RDD, since everything is explicit, they cannot optimize your code. But when you move into data frames, they can do a lot of this catalyst optimizations where even if you are doing the wrong join, they can fix it for you. Very similarly, if you look at this abstraction, this infinite table, there is no way they're saying it's a micro batch. So in the new versions of Spark, there is an idea where they may have a runtime which is kind of a real time, not a micro batch, but without changing any of the API. So that's another motivation where they come up with an API where micro batch is not part of the API, which means you just write a program, it behaves like a micro batch today, but tomorrow when they change the runtime, without changing the code, you can actually go to real time. Does it make sense? So that is kind of a motivation and why stream as an infinite table makes sense. Yeah. Correct. Okay, so that's a good question. So the question is that this ability to combine batch data with the streaming data, and it depends. For example, the Flink. How it does is it treats the file as a stream and it does a stream join. Now there is a problem with that. The problem is that the APIs to read a file as a stream, they are limited. It's a new API. You have to kind of have support for all the different file systems. But in Spark, when you read a file, it's all your existing data source API. It's not a different API which you are reading, which means all the connectors what you get in the batch, you immediately get in the Spark streaming, which is not true in the other streaming system. Because other streaming system, batch is a special stream, which means they have limited support for that compared to other batch. Yeah.
What you want to do is that there is some data coming in.
Yeah.
You want to do a least static data set, some ID kind of thing. Just be annotating the report.
Correct.
So right now this is all the in Spark.
No, you can do it in Flink, but what I can say it's not a pleasant experience.
What
Kafka streams have not tried. Beam. Okay, so if Flink can do it, mostly Beam can do it because they have a similar idea. But it is not like a first-class citizen. It's kind of a round way. But in the Spark, it's a first-class citizen because that was kind of one of the focus from the beginning. Yeah. Okay. Yeah. Okay. Now the question is, if they change in the future, that's the problem they are trying to solve now. I think when they are coming with a new runtime, they are looking at the existing runtime and saying how they are reconciling batch with the stream. Because Spark went in the reverse way. They say streaming is a faster batch. Another system says, like Flink says, batch is a slower, not a slower streaming, it's a bounded stream, right? But both are not ideal. There has to be kind of a between system, and that's what they are kind of doing the work. Where you're saying when they go to a complete streaming runtime, then how this batch joining and how you kind of handle batch altogether. Does it make sense? This is still in work in progress. I think they may have a alpha version 2.3.0, which may land in 1 or 2 months. But that's the kind of idea there. So it's not a lot of work in the API, but it's a lot of work in the runtime. So they have to now think through all this, how the streaming system will behave. Any other questions to you? From here on, what we are going to do is that we are going to go to the code and kind of try out all these different things. Make sense? Okay. All are happy? Let's go on. Now, since there is no batch time in structured streaming, now what we are going to initially focus on is a window. Because when we, all that time abstraction what we talked about, it's always important when we define a window, right? So what that means that a window says last 10 seconds, last minute, or last 1 hour. How I can use different time abstractions in the window. If you look at the HTML API, there is only one abstraction, process time, which means when you say last 1 hour window, that means last 1 hour records in the process system. Does it make sense why window and time are related? Because when I define a window, what I define based on a time. Now, if there's only one time, then it's easy. Okay, 1 hour means 1 hour. But if there's multiple time abstractions, how you differentiate between like an event window versus process time based window? Are they same? Are they different? Right. That's what we are going to start looking. Now, supporting multiple time abstractions in the single window API is tricky because when you define a window, do you explicitly say it's an event window or is it a process window, or you have it in the application layer? What that means, it may be a setting which says whatever the stream processing happening here is an event time. Does it make sense? There are different approaches. For example, Flink makes it as an environment setting, which is similar to setting in the context. Does it make sense? So what that says, if you look at the code, it says environment.set stream time characteristic, which means which time we are going to use, time characteristic.event time. That means anything which I do after this going to be a event time based model, which means if I'm defining a window, then I'm talking about the event time. But this is not always ideal because there will be a possibility where I want to do window on 2 different time abstraction in same program. Why? For example, think like this. I may have a aggregation to do which just depends upon processing time. I just want to say how many records I have seen in processing time. That's a counter. Is it a window on a processing time? Yes, because I want to know the number of records that have came into my processing system. But if I'm asking any business questions, that's a event time. Which means in the same program, there may be a possibility that where I want to ask different questions, where the time characteristic is different. So if I have it in an environment, what happens? Then I have to run different multiple stream systems which does different. One does event time, another one does the process time. So what Spark has done is very nice. What they have done is Spark does another way where you have to be explicit about the time. And by default, it is a event time. So kind of a reverse of these teams. It says you have to be explicit about the time, which means which time you are talking about. And if you don't say anything, it's an event time. And everything else is built around it. Which means whatever we're going to say it in the process time or ingestion time, we are somehow kind of telling to the Spark that it is not a one time, but it's the same API which behaves like an event. Does it make sense? Now why? Because this API was inspired by Spark SQL Window API. Anyone has tried Window API in Spark SQL? You can create a window, you can do slides and those kind of things. Similar API is exposed to Spark Streaming because they use the same abstraction. But what they have done is that they have done the event time as a default, and anything else you want to do is a bit different. Why? Because of course when the structure streaming came along, they have understood that event time is the most important thing what people are cared about. Everything else they can build by their own. Does it make sense to you? Okay.
Yeah. Maybe it will be more clear.
Sure. Yeah, I will give from now on all the examples.
When we are processing this stream, right? It should be like column communication.
Yes.
Right?
Very sure. What is that? Okay. First of all, before I get into the code, I want to show you what is a window API looks like, which will give you an indication that what I'm talking about. So in the Spark SQL, window API is a part of a group by. Because what is a window? It's a kind of an ability to group the records by some measure, right? Normally in the SQL, what is a group by? Maybe I group by a column, but here I'm grouping by time. Give me all the records for last 10 minutes, means it's a grouping condition. Now, if you look at this, there is a group by, and it takes two parameters or three parameters. First parameter is the column, which indicates that what is the time we are talking about. Now, that's why I told you it is meant for event time, because in the event time discussion, I told you event time is embedded in the record, which kind of tells me which time we are talking about. So, it's a time column. Second one is, of course, the window time, which means how long I want to wait. We have 15 seconds or something. Then there is a slide time. So, this kind of window is called as a tumbling window, which means every 15 seconds you kind of come up with a new record. Sliding window is that you keep some of the records from the last window. I think you guys know what is a sliding and tumbling window. Okay. Now, if you look at this API, what you get, one is that the time column is explicit, which means if you don't have a time column, you cannot run a window, which means it's optimized for event time. But that also means that if I'm somehow able to embed the time in the records, I'll get other systems also. How I can do a process-based window? Simple. Somehow embed the processing time into a record, then you get a process time. How I get ingestion? Let the source embed some time in the ingestion time, then I'll get ingestion time. Other able to follow how the API is built. API is built for explicit time column, which is meant for event time, but using the same abstraction, I can actually handle other time abstractions. Does it make sense? Yeah, that was a problem. Alright. Now, from now on, what I'm going to do is that we are going to discuss about different abstractions. Yeah. Yeah. Correct. Yes. So the ingestion time is source dependent. If the source is not embedding that time, then you will going to lose. But if you already have a human time, very rarely you will use ingestion time. Ingestion time is morely for kind of doing auditing, kind of making sure that if I go from ingestion to the end processing, is all the records which landed in ingestion has actually landed in my results or not. So people use that for auditing. But the real questions what you ask, if you already have human time, you will be more clear about human time, not on the ingestion time. We'll talk about that. What is the event time? We'll talk about that. Okay? Yeah.
So in terms of structure streams, yeah. Can be a stream like this, or can I have a large file in HTTP and still make it as large by using the current API?
Yeah. Yeah, sure. So the question is, can we treat a big file as a stream? You can. That's called as a file connectors. So file can be treated as a stream. The way it works is that think a folder is a stream, and every new file which comes in that time can. Or it cannot, okay, growing file is not supported, which means because the way it tracks is using create time, and if only there is new create time, then it will only pick up the file, not the existing file. Yeah, no, it will, because it is for processing, what you are asking is for picking up the data, it will not pick up that. So those ideas are exactly earlier what we had seen. Yeah. Okay. Now, people may saying, okay, event time is great, then why are we discussing about the processing time? Right? Let us forget about processing time. Let's be happy. Let's start with event time. What is important factor is you want to port your existing code to structured streams, right? Or you want to throw away all the code and start from scratch. So if you have money, you can, but not money. So if you want to port your existing GStream API to your structured streaming API, processing time plays a very important role, because now if I use a processing time as an abstraction, now I can get the exact same results, because GStream was using a processing time. Now structured streaming code also uses a processing time, which means I can correlate and see if my program is working well or not. That is the one. Second one is that maybe your source is not embedding the time at all. Right? That's also a possibility, which means you don't have a luxury of going with event time. And if you want to introduce an ingestion time, you need to now ask the IT guys to say, can you do a change in your ingestion system which actually embeds the time? This may not be feasible always. See, why I'm telling all this is, in a big organization, analytics comes in the end, right? Your source, your ingestion, all actually comes much before compared to analytics. And people in analytics typically don't have a luxury of changing the downstream systems or upstream systems. Why? Because they say, see, the analysis you are doing is actually more costly than what we are getting back. So you should not ask all these questions. Try to do whatever you are able to get. And this is true. One of the call I got last week, I was talking to one of the customers. They say, we have a product which costs 1/5 of the actual analysis money what you are spending. Can you actually reduce that? Right. So it means unless there is a reason, people will not change this ingestion system, because this ingestion system maybe use it for others purpose. Right. A lot of people use Kafka for message passing and those kind of stuff. Only for analysis, they will not ready to change. Which means by default, what you get, your processing time. Right. That's another reason. So these are the two reasons why people want to go with the processing time. Second one is that, of course, Window API does not have support for processing time, because processing time is not embedded in the data. It is something which is coming from the processing time clock. Then what you can do? But what you can do is that you can emulate it by adding a time column using some API. Okay, so that's kind of an idea. So what happens is that there is an API called current timestamp in the Spark SQL, which can be used in the structure streaming also. What that does is that it takes the process clock, it takes the like a time of that clock, embeds into your data, and gives you a new column. That's what actually process time means. Take the time of the processing system, embed that time into the data, then you get a time column. Once you get the time column, now what you can do? Now you can do all your Window API. Does it make sense what we are trying to say? So it means by default, structure streaming does not have a support for process time, but you can easily emulate a process time using a current timestamp. And also this current timestamp is always done at the like a batch time, which means for every new batch, it actually embeds the time, which means you are actually getting the process clock, not like in between clock or something. So you can be sure that, and also this is distributed, which means all the processing system what we talked earlier, it will be kind of what you say same across the system, unless you have different clocks. So that is up to you to make sure that all clocks are synchronized. If all clocks are synchronized in a cluster, then the current timestamp API will give you the process time of that system, using which you can do the process time. Now here reasoning is very simple. Why? What is my last 10 seconds? Whatever the records which came into the processing system in last 10 seconds. So the asking a question is very simple. So what I will do is that I will show you a code which actually shows this thing. So and maybe by that time I will also show you how to do other things. So okay, are you able to see the code? Cool. Now I think for the people who are seeing the first time the structure streaming, I will explain some of the things, and other code will be copy pasted from here. So one is that we don't use the stream context anymore. Everything is now folded into something called Spark session. Then what we give in this is that we give a local, we give a name, and we say get or create. We don't have to now fiddle with local up to and those kind of stuff. Spark is intelligent enough to create another thread for it, right? Now this is just a set, making sure that I don't get all these unnecessary locks. Now what I'm doing, I'm reading from a socket. All our examples are actually going to be on the socket because we have a dedicated session for Kafka. Not today, but in the future. So yeah, so I'm reading from a socket. These are the options. And if you look at the API, this looks very similar to your data source API in data frame, right? I'll say session.read and then give options and I'll get a load or something. Very similar here. Only the difference is I say read stream rather than saying a read. Does that make sense? Then I say format socket, give host, then load. What I get back in the structure streaming, by default you get back a data frame, not a data set. If you want, you can use a data set also. I think somewhere we do that. Okay. Now this data frame don't have a time column. Okay, it's just a number of like the lines of the word count. Then what I do on a data frame, I write this code with column, give a name of the column, and current timestamp. Now this with column is also your SQL API. I think if you have used data frame earlier, the same thing. You can with column means adds a new column to the data frame with some expression. Here my expression is timestamp, and what I'm going to do is that embed the timestamp. Then what I'm doing here is this word count. But if you see, now I'm converting from a data frame to a data set. The way I'm doing is that data frame dot ask, and it has a tuple. It has a string, then it has a timestamp. What is the string? String is your line, and this also answers how we handle unstructured data, because this string is just unstructured data. It has two columns. Now I write my famous word count example where I do a flat map and those kind of things. People know this. Then what I'll do is that I'll do a data frame with two things. There is a word, that is my which word I'm talking about, and then there's a processing time, which actually gives me the time in which this is embedded. Now this is the important part of the code. Yeah. Alright. Now if you see this, what I'm doing, I have a data set, I call a group by. Inside a group by, I'm giving a window. It has two things. This dollar says it's a column. I'm selecting a column. I'm selecting this column. I'm saying 15 seconds, which means for every 15 seconds, give me the window which actually does something. And what I want to do, I want to do a count, which means just count the words which I'm printing here. Then what I want to do, I order by a window. So when you do a group by window, it creates a new column called window, which actually captures the time for that which the window is created. Because in the group by also it does the same, right? In the group by it creates one column for that group by, and then for that group by column, what is the value? So that's why I'm ordering by window. Then this is the way you can output to a stream. So here I'm outputting to a console. Truncate false means just show me everything. Then output mode is complete. Because in the structured streaming, there's a concept of output modes similar to your save mode in the data frame API. I can say append, override, and those kind of things. In the streaming, it's a little bit different. By default, there can be like maybe append, which means just show me the last batch results. Then there's an update, which means only show me what is changed, and there's complete. Show me everything from the beginning. Typically, whenever you do an aggregation in the streaming, it has to be complete because aggregation can go over multiple batches. So that's why I'm saying here complete. Then I start a query, have a termination. Any questions here?
The column that has what you are giving inside that window.
Yeah, it should be what I have given here. It should be same. It's just a column which I have specified. There is a different APIs to do it. This is one way to specify. Other fine till here? Now, it has three columns. Actually, it has a window. No, it actually has window, word, and count. It has three columns. I'm just, I think, printing just to count and the window. I'm not selecting the word as a Alright. Does it make sense to you? To see that, like if there are if there are multiple, so here I'm not actually done the sliding window, but if you have a sliding window, you can have multiple windows at the same time, and they are sorted by the time. That's why I order by window. Okay. Now the question is how it works. To work, I need to have a How I zoom? Forget. Command plus. Okay. So everyone is able to see. Not yet. Oh, command plus. Fine. Okay. So what I'm doing is that it is the easiest way to create a stream. It's a socket I'm listening on. What I'll do is that I'll start my program in the IntelliJ. Okay, let it start. Okay, doing some compilation. Not needed, but we'll do. All right. So now, before I start with the example, now people will say, where is batch time? But how I know, is it a window time or is it a, how? By default, there is a concept called as soon as possible, which means as soon as you get the data, Spark starts processing. So we'll show you what I mean. So let us give some data. I'll say hello, how are you? And let's see what happens. It says it started up at 0 because it got a data. It will show a window. Even if the window is not complete, it will show you. Do you see this? It has actually a start time and end time. And it says, oh, what is the count? Make sense? Okay, now 15 seconds are done. Now let me enter something else. Okay. Now what happens? You see two windows now, which are so they are differentiated by 15 seconds. And this is the reason I also sorted, because if it's complete, it will remember all the windows here. Now you say, okay, but can I see batch starting and then not doing like within 15 seconds I enter something else and it's showing up? Okay, that's my challenge now. So let us say, okay, started, then I'll give something else. Let's see what happens. See, you have this window, then there is a new batch what started. You see that it went from 2 to 4. Which means if it, within 15 seconds, if it gets the data in the processing system, it updates the existing window. Otherwise, it just forgets that window, moves on to the next window. Does it make sense? So what 15 seconds here means? Last 15 seconds which came into the processing system, it will just, it's very similar to the SQL API. Writing is a little bit different, and the way you observe also is a little different. In earlier it used to show something else, but this kind of shows you the data frame. Successfully executed. Okay. Now it starts becoming interesting, because till now we are just talking about our normal movies, right? Okay. Now, what about ingestion time? So I will not go to event time, because event time is like I told you, Rajini movie. You cannot start with the Rajini. So what I will go to that, I am going to give you an in-between thing, which kind of start giving you a flavor of what is the difference between the process time of any other time. Because yeah, sure. Yeah. Okay, that's a good question. By default, forever. Forever. Yeah. And the question is how to make sure that we drop those windows. We have an answer to that. That's a good question. Any other questions to you? Alright. Now what I want to do is that, now let us say we want to talk about ingestion system. What that means is that, think of a problem where I capture the data in the real time, but processing takes time to do for every time. For example, let us say you have this web pages which you want to crawl in the real time. So what web pages to crawl you are putting in the Kafka, which is instantaneous, but crawling the every web page will take time. But if I want to ask a question, what are the websites I have captured in last 10 seconds, I want to go with the ingestion time rather than going with my processing time, because if processing takes more for one web page, my answer will be wrong. Are you able to follow what I'm trying to say? So ingestion time helps us to get better result than processing time without worrying about out of order and those kind of things. Because out of order normally happens when there is a slower network or something. Yeah, we are fine. We are in the same data center. Ingestion time support is dependent upon the source. This is something I was telling you. If we source has to embed it, not on the processing time. But we are lucky. Socket team supports the ingestion time. And if you are using Kafka, it also supports the ingestion time. Now the question is, how we do this ingestion time and how we see the difference. Okay, let's see the code. Now, it is exactly the same code, but I have done something. I did this thread.stream kind of to emulate that delay. So what happens is that the data comes into the system. It takes 15 seconds to process, so that when it actually clears the window, it has to be ingestion time, because if it is a process time, by the time it is completed, it will move on. Does it make sense what I'm trying to say? So I have added this extra delay. Now the question is how to try to socket that embed time. So this is an option here. So I can put an option in the socket which says include timestamp, which will make sure that I have a timestamp with me. Does it make sense? That's why I told you it is a source dependent. Source has to do the work. And where I get the thing, by default it puts, so normally in the socket I get a word, that's a string. But if you see in this example, I got both string and the timestamp. Why? Because now source is embedding that timestamp. I'm just giving the name called as timestamp by myself. But when the socket is sending the data, it's sending me the line and also sending me the time. And where the socket gets the time from my desktop, right? Seconds. Then everything is same. Okay. Any questions still here? Does it make sense?
Timestamp also what the way you are
Yeah.
is it like hardware?
No, you can give any name. It just gives you two columns. There is no names to them. You can give any name you like. Clear? Fine. But now the magic happens, or supposed to happen. Let us see. Now what I'll do is that it started. Nothing is happening as of now. Let me give some data. Now if you see, it will start processing. I'll go back and just give another thing. But batch 0 will take more time, but in the ingestion I've just went back and within 15 seconds entered one more thing. But if you see here, first window will take more time to come because I have given that thread.c. Will wait for 15 seconds. 15 seconds is long in your presentation. Because when I'm writing, I cannot enter within 15. I had a 5 seconds. But let us see. But it should give you first window batch 0, then batch 1, then one window which is getting updated. That's what we are looking for. Okay, you see that we got 2 because it took a first line, it started processing. Of course, you have to wait for the next 15 seconds. That's fine. But the idea here is that it should update the same window because ingestion was done instantaneously, even though the processing took us more time. So let's hope it comes to the same window. Yes, yes. It's just how you, what do you say, do all those if out of order and those kind of things.
Because for processing time, they are extremely column.
Oh, then I was late I think. Okay, that's fine. Let's yeah. Okay, I'll say okay and 2 lines. Okay. Let's hope it's not picked up both on. Right, yeah, so what I was saying is that, yeah, so what happens is that whatever the timestamp it gets, Spark uses that time for tracking the time. So we'll go a little bit more in the event time, but the idea is that whatever the timestamp it gets, it uses that time to say is it 10 seconds or 5 seconds. It will compare from the last record to this record saying that if the time happened to be last 5 seconds or something. So the Spark does not use any, it's built in for time in order to track. It means in the structure streaming, time is explicit. If you want to use a process time also, you are being explicit. You are not, there is no implicit time in the structure. Because in the GStream, there is implicit time of process. What happened? Okay. So I can show you that it is not actually using the processing time. If there is a 15-second happened in the processing time, which means it took a first record, it took a 15 seconds to actually to process it, which means if I am using a processing time, already I have done those 15 seconds, should be a new window. But if I have ingested them in the same time, even though 2 records takes a lot more time in the processing time, they are grouped under sync. So what happened is that both are got grouped. Only thing is that it ran in the same batch. Or is it 2 different batches? Oh, okay. Yeah, if you see, what I was saying is that this line came when I entered the first line and given. But that took a 15 seconds to process, right? But even though that, if you look at the time, it still came under the same window because in the ingestion time, we are not done the 15 seconds. It was like 2 seconds. But the processing, it may be like 30 seconds now because 50 second time between two. Which means in the processing, it took 30 seconds to process that 2 records. In the ingestion, it took 2 seconds. Now, window, which the window it's using, so now that's why I say start getting all complicated. Which time I mean, but this is what I wanted to show. Even though your processing system is slow, you do not worry because you always know that your answer will be right if you are using the timestamp of input. Does it make sense to you? This is what we wanted to really discuss, right? This is what people, when they move to structured streaming or real streaming systems, are interested in. Like how you do it on event time. Because process time is okay, ingestion time is good, but that's not really gives me what I want. What I really want, I want to ask questions depending upon what happened in the source, not on the ingestion system or not on the processing. Does that make sense? Okay. Now, what is the event time really and why people care about it? One thing is that event time is a source of all the truth. Correct? Which means what happened is actually known in the event of the source, not in any other system. Like ingestion may be delayed, everything can be delayed, but the timestamp what is captured in the source is actually always true. And as more and more stream systems are sensitive to the time, event time plays a big role. Why? Because these days, if you look at the all the stream processing systems, a lot of people are very sensitive to the time, right? So what time it happened. For example, if you have a system which gives you offers, again, when you collect the data, you want to go with the event time, not go with the process time, because maybe more people will get offer or no one will get an offer because something got delayed. Same with the, let us say, if you are a Uber or Ola kind of system, where when the trip happened really on your phone or something, that makes more importance compared to your when it got into your event or those kind of things. Which means more and more processing systems are now very, very sensitive to time, which means they are really sensitive to the event time. Event time, one of the advantage of event time, it helps people to correlate in the events. So what that means? Let us think about a scenario where you have a system which analyzes your microservices. Right? A lot of people use microservices these days, right? There is a web application, then there is a cluster, then there is a UI. Now let us say something broke. Okay, so what happens? Each of the system will log saying that I broke this API, I broke this API. Now you need to correlate these events to make sure that why something got broke. Typically it is called as root cause analysis to make sure that from what it got broke. Now think, first two systems sent the data in first 15 seconds. But next thing which came like after half an hour, when you correlate, they don't make any sense, right? Okay, this came like some time back and this that should be independent. But in the reality, if you look at the event time, they are correlated because everything happened, let us say at 11:30 p.m. of a system. But when they came to us, maybe something came in 11:40, something came maybe at 12. But still, they are related events. Which means if you are doing multi-source analysis, event times plays a big role. So which means it helps you to correlate different sources rather than restricted to one source. Correlation of events within and across is important. That's why event time is a default abstraction for structured streaming, which means it actually encourages you to embed the data, like a time in the data, which means it encourages you to use the event time. Now, what is the challenges with the event time? Right? If it is so easy, people would have used by this time. Event time is a very good idea, but it's complicated. It's very similar to saying doing movies like Bahubali is a very good idea, but it's very difficult. Right? It makes a lot of money, but it's very difficult to get. Why? Why it is difficult? One is the time in the source may be different than what is the time in the processing system. What that means? Which means the system may be generating a lot of events in the sensor, but maybe it's disconnected for last 30 minutes. Which means there is nothing happened in last 30 minutes there, but processing systems already moved on. It's just turning more and more data. Right? That's always there. Second one is that how to handle out of order. That's also important. For example, let us say you got a message at 11:30, something happened, but there was another message preceding that which didn't come to the system. Maybe because it dropped or maybe it got delayed. Which means if you are correlating, what happens if there is an older event? Do you handle it or do you ignore it? All those kind of things will come into picture. But in processing system, there is no concept of out of order. Everything is in order and everything starts on the same clock. Now, how you correlate events? from the sources which run on their own speed. That's also there, right? Sometimes one source is like giving you like 1,000 records, another is just giving you 2 records. Both on the same time, but they have their own speed. Maybe someone is sending very fast, something is sending very slow. Do you wait for that slow system to come back, or do you wait forever? All those kind of things. For example, it is a very famous analogy I will give is, see, typically when we have a project, it starts with a one developer, right? So you start coding, everything's fine. Now what people managers think, adding more people will increase the productivity, right? That's what we think, but not really. Why? Because everyone has their own speed, and you need to correlate their speed, because otherwise the output will be completely different than what you need. Then you start getting into all these issues. Similarly to that, event time also comes with that. Another one is that how to reconcile event time with processing time. What that means is that, let us say data came a little bit late, but you already processed some of the data, which means there is 2 times now. There is some data which is already processed, which has process time. There is some data which is not yet processed. How do you correlate it? Or can you correlate it? Those kind of things. So there are challenges. Now, from now on, what I'm going to do is that in each slide, we take up each of this challenge and say how structured streaming helps you to handle some of them. Okay? Before anything, we have to first of all do the how to do a window on event time, right? So what we do is that event time will be a column, which means we don't need to generate a column. It's there in the data. Default window API is built for this kind of use case. Now, what kind of an example? Till now, I think we took an example of word count, but from now on, I'm going to be an investor. Now, how many people invest in things? Stocks. But don't worry, I'm not selling any mutual funds or something. I just wanted to see, can you correlate to this? So, what is the system we are building here? Is that I am building a stock analysis system, streams analysis system, which kind of looks at the different signals in the stock in order to figure out how the stock is behaving. Now, if you look at this, here event time is extremely important to me, because if the 12:30 this happens in the given stock, I don't want it to know it's like 1 o'clock here, and I want to get all the events for that 12:30 at the same time rather than correlating across the process time. So this kind of system, what the data will have, the stock system will embed that data. Okay, this was a stock price at this point of time, and give it to you. Even though it comes 1 hour late to you, no worries. You can get like from 12:30 to 12:40, what was the stock price, irrespective of it comes immediately or is it come at the no. Are you able to follow? Now, why it is important? I worked for a client a few years back. What they do is that they look at the trend of a stock irrespective of other sources. What that means is that, let us say what we are analyzing is Apple stock, because it is very big stock, it makes a lot of money. So they look at all the sources and wait, this is how good information about Apple came out, is the stock is changing. Or maybe whole industry of mobile phone is gone down, does it affect the thing? Which means you are correlating the same time. Let us say there is an article came at 11 o'clock in the morning. Does it change the system immediately at 12 o'clock, or is it having any other pattern? Where you are correlating the time in the real world, not at the processing time. Maybe your article came in at 11 o'clock, your Apple stock data came in 1 o'clock. They are not too different. They are same. You just want to correlate. Of course, we are not going to do all those things. That's only for example. What I'm going to do is I'm just doing this count over a time. I'm going to show you that it actually uses an event time, even though I delay it in the processing system, or if I'm lazy, I'll just ingest very late, no issues. It still makes sure that it's actually taking the time of the source, not the time of the ingestion or of the processing. Does it make sense? Okay, let us see an example. Okay. Right, so if you see the example, here I'm using a little bit of structure because it helps you to explain. If you see this thing, case class, right? So I have a stock which has 3 information. It has the timestamp, which timestamp I'm talking about. It has a symbol. Symbol is every stock has this APL and those kind of things, which means you can analyze multiple stocks at a time. And it says, so what is the value of that stock in that point of time? This is from the source, like that. Then everything is same. Here what I'm doing is that I'm converting into my, if you see there is no time in the socket, I'm converting my data into a stock. object, that's my data model. Then what I'm doing? I am saying, give me the value, that like, what is the total sum of the stock in last 10 seconds. Yeah, last 10 seconds is whatever the events are generated in the source, give me the kind of what is the total value of the stock, right? Then just print it and open it. Does it make sense? It's not too different. Now, only thing we have done is that rather than using a processing time, that's the current timestamp, or using a different time, now directly we are passing the time in the record and using that time to create a window. Does it make sense? Alright. Now, how we run this? Okay, so let us run this thing. It still uses a socket. So now, alright. Now what I'm going to do is that this is very interesting. I am not analyzing Apple stock for today. It means I'm not talking about ingestion. I'm not talking about Apple stock of now, not a processing time. I am analyzing some time which is completely different than what is the date. But I can still do analysis because I'm using event time. Are you able to follow? That is one of the strengths, which means I can do actually this reconciling backfills using this kind of API, right? Some people, like for example, if something is broken, you want to do a backfill, you can use a event time because it's the same time in the data, you can do a backfill. Now, what is the thing? First thing is that if you look at, this is the timestamp which is for Wednesday, 27th April 2016. That is the price of the Apple stock. This is in dollars, $500, not real money. And that is a timestamp. I'm just using a Unix timestamp and putting things. This is my input. Let me give the input. Okay, so which means what Spark does is that as and when it gets, it started, if you see, now the window is actually the window of the time. This is not our 2018. And it's starting like 2016 to whatever the date is. I think my comments were wrong. It says, okay, it says 500. Now I'm talking to you, which means all our 10 seconds is done in the ingestion and also in the processing. But don't worry. So what I'll do is that there's another event which happens after the next 5 seconds. So I'll just copy paste this and enter here. So what I've shown you is that there is a delay in now ingestion because even though it is 5 seconds there, it came like after some time. Do you see that it just gets updated? Does it make sense? Alright. Now there is an event after 11 seconds, which means my window should be complete and it should create a new window. Okay, let's see what happens. Do you see this? Right, now question is what's going on here? What's going on is that Spark is saying until I see a time in the record which has moved on, I will not change my time. Because my record told that okay, there is a 11-second record has happened, which means okay, source has moved on, let me create a new window and start. Till that, I always keep the same window. And which how many windows we are keeping? We are keeping both. This was for first two records. This one is for thing. So what is the time in the source now? It is the time is 17:40. Right here. Are you able to follow? Now we are not restricted by ingestion. We are not restricted by processing. And you can take actually any time series data and play like this. Because the time, beginning time of the system is actually beginning time of your source data, not your ingestion or any of this. Can you do this in the current system? Not really. What you need to do, you have to write a query by yourself in order to do that timing, not using the framework itself. Framework just says this is 2018 and then you will do that grouping yourself and go from there. Here what I'm showing is that system is able to log. Now there will be questions. What happens if there is an event comes in between of that 11 seconds and early? Do we still take it or not? So what I'm saying is that now the system will say, okay, it's 17:40. What happens if there is something in between of that? Okay, that's the late events. What is a late event? So in the processing system, there is no concept of late event, right? Because you got it, your time is moved on, whatever you get, you get a new timestamp. But in the event time, there can be possibility of late event. What happens is that I have started a new window, but there is new data comes in to the earlier window. Now the question is, do I update the existing window, which means I have to keep around the window, or do I just say, oh, I don't care, maybe I have enough data, I don't care. Some of the use cases it's fine, because if you are not looking for an absolute value, there may be one sensor which is setting a lot. If you are analyzing like 100 sensors, then you say, okay, I am not going to wait for that for forever, right? But what is the default nature? In Spark, default nature is it keeps the windows forever, which means you can handle late event forever. Even it after comes after a day, it can handle it. So I will show you what I mean. Let us say, so I have an event which is kind of in between, which actually belongs to the first window. What I'll do is that, sorry. Do you see this? This 1100, now this got into 1300. Make sense? So it means by default, if the Spark has a late event, it just it's a great for application, right? It means you can tell to your manager that don't worry about late events, I can do it forever. But there is an issue here. What is the issue? If you start using all your resources, as the time goes, the number of windows what you are keeping around is infinite. Think like this. So I will give an analogy. Think that you don't have an ability to forget, right? So what happens? You are overloaded by information, right? All the things what you learned in the school will be still there. Whether you need it or not, they will be still there. But what is a boon? We can forget. It means after the exam I can forget what I need or what I don't, so that I can learn new information. Similarly, in a lot of applications, I don't want to keep late events forever, because that's a costly to build. What is costly here means, because internally a window is implemented as a state in structure string, and the state needs RAM or disk. And also when you compute, you are doing a joins with the multiple windows, which means it takes a compute power. And if you are keeping a window forever, what happens? Then your resources are going to be consumed more and more as the time goes along. And after some time, you will be running out of memory or running out of space, those kind of things, which we don't really want. What we really want? We want to have a delay between the actual time and how long we want to wait. What does that mean? For example, I want to say, I will wait for maybe 10 more minutes for old event. If those events come in those 10 minutes, I'll be fine. Otherwise, I'll just ignore. Does it make sense what I mean? Right, this happens in the Meetup also, right? We wait for first 20 minutes, people will come in and say, we will wait for 5 more minutes, but we have to start some part of it. We have to drop the state, right? Similarly, in the lot of systems, I want to give this delay where I say, I don't want to stop immediately after the time is moved on. I want to wait, I want to give a, option to people that they can set the events by that time. If not, I will move on. Now, this concept is called as a watermarks. Are you able to call what is a watermark? Watermark is an ability to say to the system that I want to wait for some more time. After the time is actually moved on, then you can actually drop those events which has come to the system. Why it is called as watermark is it's kind of an indicator in the stream that after this, I have watermark that all the time is moved on, you can continue. Anything before this watermark, I'm not going to care. You follow why it is called as a watermark? So, right. Now, how to implement a watermark? Actually, different systems implement it differently. For example, Flink has a watermark in the source itself, but in the Spark, it's a little bit different. In the Spark, it's just a threshold time. What is the threshold time? The way we calculate, should we keep the state or not, is it says it's the maximum event time seen by the engine, which means 11:30, let us say, minus the threshold. If it is greater than whatever the timestamp you are seeing, then drop it. Other than till that, you see. What that means, let us say my threshold is 1 minute. I will wait till 11:31 to get the data for 11:30. After 11:31, I just say I have moved on. Anything which comes after that, I will drop. Does it make sense? Yeah.
Maximum time
Across the executable. Yes. So here, when I say maximum event time, it is for the batch. So in the batch, what is the maximum event time I've seen? Which means, do I have a record which kind of says 11:30 across the executors that in the batch? Then I say source has now 11:30 time.
No, but the data is that the
But the concept of batch is across the executors. So in the conceptual, it's a batch. Implementation is a bit different. But in a batch, it says what is the maximum time I've seen. I think this one I have not explicitly mentioned, but I think people have understood. Now, how Spark knows it is 11:30 in the source? Because it's not its clock, right? Idea is that it looks at what is the maximum time it has seen in the records. That is its time. Which means if you get a record for 11:35, that means that source has now time of 11:30. Does it make sense what I'm trying to say? Okay. Now, let us see the example of watermark and how to give a watermark. Yeah. It actually just drops that window altogether. So that okay, I'll talk about that code, but it will not remember that window anymore. Okay. Now all the code is same. I'm still doing a stock analysis, but one thing I wanted to focus was two things. Do you see this watermark? The first parameter takes is which column is used for watermarking. You can use actually different columns for watermarking versus event time if you like to, but typically they are same. I'm saying 500 milliseconds. Wait for 500 milliseconds, then drop. Then everything is same. But one thing you see, I have now changed from complete to update. Now what that means? If you say complete in the structure streaming, irrespective of watermark, it remembers everything. That's why the name of complete comes out. But if you say update, it says only show me the window which got changed. Then it kind of adapts to the watermark, which means if there is no window which is going to change after this timestamp, it just drops all those states which is not here. Other follow. If you are using a watermark, make sure that use the update. Don't use a complete. If you use a complete, it does not matter because complete means that remember complete state. Update means that only remember what is relevant. The relevancy comes from watermark. Does it make sense what I'm saying? Okay.
So even if you don't use watermark and use update,
It will not work. It will still remember.
the windows won't be.
They will be not wrong. Update will only show you what is changed, but those windows will be kept around. If something changed in the earlier window, it will still show up. So the question was, if I don't use the watermark and use update, is it going to drop the window? No. What the update in that sense means is that it only gives you the change to window, but that change may be older window also, which goes forever. Update with the watermark gives you the ability to drop the windows as and when the time is. Does it make sense? Okay. Alright, let us run this stuff. This is the same data I'm going to give because the same example.
And dollar include what you
Yeah, it's just I wrote in a different point of time. So I copy pasted the underneath one that I wrote in between. So no, you can use any way you like. So the idea is that if you just give a name, it is a string. If you give a dollar, it is a column. It's exactly the same. But API actually, most of the APIs allow you to give a string or a column thing. But the advantage of doing dollar is after this I can use uppercase, lowercase. I can do some column related transformations which I cannot do with a string. How do this? But you can use okay. Yeah, why it is giving me problem? Yeah.
Alright, so I will do all this thing fast. So let's see. Okay, now what you see is that it only shows the chained windows. It will not show you everything because so first window is here. Then I will create another window. Now this is the window which is getting chained. That's why it will show you the window. Now if I enter this, you will see there is another window will show up. But it will not show the older one because this window not got changed. If you see, it only shows you 400, not 1100 because that window is not changed. It is there, not changed. Now what happens if it is a late event? It's already 500 milliseconds. You see this? It's lost. No window is updated. Why? Because earlier window is time is moved on. There is no window to show up here. It is not. Does it make sense? No. So the time is moved on. Any event before the time will be not considered at all. Because if it creates a new window, then there will be like intermediate window in between. So it will just ignore all the events before that. In the processing time, what happens? In the processing time, it will create a new window. Because it says, okay, it's a new column, I'll just start here. But in the event time, it just says, no, time has moved on. Then I'll just ignore all the records which are coming. Typically, what people do is that in the streaming system, they just do like this. But in the actual system, they run a batch system after the fact so that whatever the events you have missed in the streaming, you can reconcile after the fact. So that's how people handle it. For example, you may say, okay, those are important records. I don't want to ignore. Then run a daily job in the night, which actually goes and updates correct results. But in the streaming system, you are passing. So that's what your Lambda architecture is. However, to follow, you still have those data in the ingestion system. It's just that not considered in the streaming. You can reconcile after the fact. Yeah. You mean if the one batch is bigger than, there is not a good way. That's not good. It's similar to your reduce by key problem, which means you need to create the new keys and those kind of stuff. But I think if you use the event time, it solves some of. Correct. In the streaming, typically what you do, your infrastructure is tuned for peaks. That's the only way people normally handle it. Which means you compute what's the peak data thing, then you kind of put our resources for that. So there is not a good other way. Otherwise, what you do is just ingest in the same speed, but the pickup speed may be normalized. Which means it does not give you a real time, but it will make sure that your processing system is not overwhelmed because ingestion system is sitting in between, which will give you the constant stream of data, something like that. Yeah. True. That always happens. Okay. So till now, we have talked about Window API in terms of time. Right? So I give you an example of linear time, then there is a ingestion time, then there is a event time. Now you may say, okay, that's complete of the movie, right? What else is there? Wait a second. Now think of a place where there is no time at all. Then what happens? But people have made movies even that, like for example, okay, if there is no time, what happens? So there is a movie, I'm not sure if it's a movie, but there's a book which talks about there is no concept of night and day. Right? Then what happens? Something like that. But here we are talking for some other reason. So which means can this idea of window go beyond the time? Right? It can. Let's say an example. Now, what is the need of a timeless window? So I just like the word timeless, so I'm just using it, but it's not called as a timeless window. It's a window without our time. Most of the streaming applications, time is the king, but not always. Like there are other ones, like Queen and other things. But there are use cases in streaming where state is not bounded by the time, which means I told you window was created for keeping the state. last 10 seconds, last 1 hour, that's a state. In scenarios, then we need an ability to define a window which is not based on a time. One of the advantages of structured streaming is, since it can support multiple time abstraction, it can also support an abstraction where there is no time at all, because it's flexible enough to support all these kind of different window structure. Now, what is an example? Why we care? One of the famous example is sessionization. And what does sessionization means? Let us say you want to analyze some information depending upon user sessions. For example, if you have an e-commerce system, some person comes in, logs in, they start a session, they are looking around the things, and after some time they go away or they log out. Now, if you see end to end, that is called as a session. Does it make sense? If you look at this, it is not bounded by time. Can you say every session will get done by 15 minutes? Not really. Some session may be just 2 seconds, some may be like an hour, or maybe people are in the shopping mood. It may go for multiple hours. Right? Now, why you care about session? It allows you to understand user behavior in the session. Why? Because if you look at the lot of analysis, what we really want to say, how user is moving in the system. He landed on a page or she landed on a page, then they went to an offer, did they take an offer or not? If you look at all this correlation of thing is not based on time, but this correlation is done on the session layer. Which means person has landed, then after a long time, they have moved on with the different parts of the application. Does it make sense? So this is one of the scenario where I don't want to create a time-based window, because in a time-based window I have to always keep on checking, is the user still in the session or not, all those kind of things, and there is no good way to design it. Like, how I know how long the session is? Who knows, right? So that's why we can create a non-time-based window to solve this kind of problems. Alright, so session is not purely time-based interaction, because sessions can go in a different time. Now, what is a session window? A session window is a window which allows us to group different records from the stream for a specific session. That's the definition of a session window. Window will start when the session starts. It depends upon what the session start means. Maybe in the mobile app, someone opened the app and they are using it. Maybe in a web application, someone logged in. Whatever, it depends. In a credit card, maybe they started using credit card, something like that. Window also supports multiple sessions at the same time, because multiple customers have having multiple sessions. Sessions windows are often analyzed typically to understand different interactions across sessions. That's what session window is important. Now, how we implement this kind of a window in structured stream? Do we use the same API? Because window API didn't have anything called session, right? We just had time and how much time we want. Right. In structured streaming, there is no direct API to do a session window, because our existing window API typically says there is a time. But what we are going to do is, we know internally window uses state-based system. Now, what does a window means? It's a state which starts at the beginning of the window. It is kept till the end of the window. Does it make sense? Now, in the Spark structured streaming, there is an API which allows us to play with the state directly without actually have to go through the window API of the structured stream. Does it make sense? So what here we are doing is that we are not actually using the window API, but we are using the underneath framework which is actually supporting the window API. That's the state management, and the API what we are going to use is called as map group with state. The name itself says map means I am mapping some data with what? With the state. Are you able to follow what that means? Okay. Now, people who have done the DStream API, you may have gone through this map with state. How many of you use this map with state API? Similar idea. Now people say, okay, we are taking time. Now, what is this thing? Let us see. I will go step by step so that people can understand. Now, first thing is that I have to model a user system, how it looks like. Right? If you look at the first case class, it has three information. One is what is the session ID? What is the session ID? It uniquely identifies a session. Very similar to your web application, you embed a session ID, right? To say that who's that person. Then there's a value. Here I'm just having a one value which tracks that session, but here realistically you have an actual event and those kind of things. And there is an optional field which says end signal. What this? This is a signal which says session is ended. Maybe timeout in the client, or maybe there is an explicit event from the user saying that I am done with this application. So, okay, now timeout, if you see, it is not a part of the record. Why? Because timeout internally will generate our end signal, where we are using that end signal to go ahead and do it. You can implement server-based timeouts, but I'm not going to discuss about that because that will bring a time into the picture, and it's not going to be a timeless window. But you can do it. I'll show you where you can plug in that. Does it make sense? What is a user looks like? Okay. Now, whenever you do state management, there are few other models to look at. So there are two models I'm looking at. One is what you want to keep for a session. It is a state, which means you have to define what I want to keep. If you see, I'm creating a model which is called a session info, which keeps a single number. What may be this? It just aggregates all the values in that session. It means if the session is started, I got a value 1, 2, 3, I just keep on aggregating into numbers till that session completes, which means the final number will give me what is the events happening in that. Does it make sense? Maybe your use case is much more complicated, but here it's very simple. And second one is that for every batch, I need to tell to the system that if this session is still valid or not valid. Does it make sense? Because session can be go across multiple batches. So what I'm saying which is the session ID, that's my ID. It says till now what is the total sum. Till this batch total sum is this. And it also says expired equal to boolean. But that means is that session is expired or not. Does it make sense? Okay. Now, let me not explain this slide. I will go into the code. It makes more sense. Okay. Sure. Yes. It depends upon you. If you want to wait forever, you can. But there is also a server-based timeout. I will show you that.
In this case, we have the bottom of this session is closed, and then later I got some email saying that this guy purchased something.
Yeah.
Of the session.
The watermark what you have shown, it was a time-based. You have to implement that watermark yourself. It will not allow you to do it. Okay, the first 3 lines were those things I talked about. Then follows right, session info, session update. Now, what else I'm showing? Till here, everything is fine. Okay, now here I'm parsing that information. I'm saying the column 0 is the ID, this one is the data, it's optional entry. So here I'm saying if there is a column 2, then it's the same thing, otherwise it's none. Okay, now all the magic starts happening. Now, if you see, I told you normally window comes into a group by. Same in this, because if there are multiple sessions, I want to differentiate one session by another session. Does it make sense? So that's why what I'll do first, I'll do a group by on a session ID. Are you able to follow? That's why the API is called as map on group. Not on the single data, it's map on group. So what I'll do now? Okay. So the second one is that after I do the group by, I write this API, map groups with state. Okay, what is the parameter text? It says, tell me what is the state you want to keep. That's my session info. Tell me the model which is used for updating the session, which means it says what is an update. And do you see this timeout? This timeout allows you to do server-based timeout, which means you can say, like let us say group state timeout, process time 10 seconds, but it does after 10 seconds, it will just timeout that session. So using this, you can implement server timeout, but as I told you, we are not going to do timeout. That's why there is no timeout. I say, I don't care, I want to keep it forever. And also this timeout acts similar to that watermark in between. Not fully, but something like that. Now what I'll get? I get the session ID because I'm doing the grouping. Then I get this iterator. What is the iterator? All the records for that batch. Does it make sense? Because everything is batch based. Then what I'll get? I'll get the state, current state of the system. Session ID, the data for that batch, and the current state. Using this, I can update the state or I can drop the state. Okay, what is the logic? The logic is that I'll see if the state exists, I'll update the state like this. If you see, I'm doing the reduce. Then, how to update the actual state? I say state.update updated session. Now this is similar to update by key in the TST. You may have seen this where I can say this is my key value pair state. I want to update this by this key by this RDD. Very similar to that. I'll say I'll take all the records, do an aggregation for that section, go ahead and update the state. Now the question is, how do you know which key we are talking about? You don't need to worry because we already done the group by. It knows which key we are talking about. Okay. Then what I'll do is that I go ahead and see, is there any end signal? What that means, if there is an end signal, which means my state is done, what I'll do a state remove. I send a session update which says session ID, updated session, total sum, it is expired. Otherwise, let's say it is not expired, let me continue. Doing this state update and state remove is an ability to play with the state explicitly. So here what we are doing, we are saying to the path ourselves, you start the state, that's when it starts with the group by. I am going to update explicitly using the session update. If it is expired, I am going to call state.remove, which explicitly tells the Spark that state is complete. Now you can remove from the system. Does it make sense? Is it too complicated? Yes, it is. Here, it takes as a parameter. You see that map group with state, and then there is a case, right? Session ID, event iterator, and it gives you the current state. So that's the state I'm talking about. Does it look complicated? It is because it is something you do when you are doing an advanced processing in your system. Typically, you don't do this if you are playing with the time. Everything is built in, but here we are talking about. So yeah.
One more thing. Here you have done group by one column.
Yes.
Is there a possibility that you can do
You can. That is a complex key way. That means you define a complex object and you can group by a complex object. There's still a single column, but a column can be derived by multiple values. Something. Else is if there is an end signal, you remove the state or give a session update. If it is not, then you get the session update which just says this session update is something what we're going to print it, saying that is this an update for downstream system that is it the session is completed or it's still going on. Maybe you are, let us say, saving it to a database or something like that. So this allows you to give those updates to the downstream. Does it make sense? I love it. Okay. So let me run this, and I think then it makes so much more sense. Is anything is running? Not really. Now I don't have to worry about time because it's a timeless, right? So let us. Okay, so I'm using a socket. So I create a session like this. It's a very simple session. So if you will see, I just count like doing a sum. The session 1 is started. Then I'll give a session 2. Yeah, so since I'm using an update, it only shows what's changed. I can give more things. It just goes ahead. So even if the update was last one, you see that it's not removed the session 1. It just only shows what's changed. Session 1 is still in the memory or in the state. Then, okay, let me end the session 1. See, now session 1 went along. Now it says expired equal to 2. Okay. Now what? Now, so if I give a session 1 again, now this was a question. What happens if I give a session 1 again? Does it behave like a watermark? Not really. It's just a key and value pair here. It creates a new state from there on. So it just treats as a new one. So it just gives you a session 1 now. And the session 2 is not expired, it just is there. So if I give session 2 equal 200, it actually updates that session 2. Now it became 400. So session 1 newly got created. This one is now updated. So this kind of system allows you to now, not bounded by time, you can implement any kind of logic which is very complex kind of an event or a state using this kind of API, so that you can do this kind of analysis which is not bounded time. This kind of thing. Of course, when you get into this API, you need to do some of things yourself, like timeouts, watermarking. If you get default in the time-based windows, you will not get into this kind of. This is called as custom state management in Spark API. Okay. Where are my? Alright. So that completes our discussion. So for references, of course, first reference is all the blogs I wrote. So this was wrote like 2 months back. So that's why you see the inconsistent in code and some of the things I have got added over time. So when I started with the time windows, but over time I started doing this synchronization because we had one example in Flink how to do synchronization. Then Databricks actually wrote a very nice, I think, a blog series which talks about how to do ETL with the structure streaming. That's one of the good use case to do structure streaming. And I use a lot of Flink for learning structure streaming because it just copies the most of the ideas anyway. So if you are interested, you can go through this Flink thing. A lot of people learn structure streaming by Flink. So you can try that out.
So is it related
API is related, implementation is different. The idea of event time and idea of watermarks all are there in Flink also, in Beam. Okay,